Hey, AP Chemistry, this is going over your Unit 2 test, the test that was done in class. Question number one, and recall that there's different versions, is asking about infrared radiation. What happens when that's absorbed? And that's when molecules are going to vibrate. Now, hopefully, you realize if it's light in the visible spectrum, kind of your Roy G. Biv, that's where electrons will get excited and create visible light. Molecule rotation occurs with lower energy than infrared, which would be like microwaves. And if it was high energy, possibly UV, specifically UVC, the highest UV energy, or if we get into the X rays category, electrons would be ejected from the atom. Number two on here is a very common question in that what it does is it looks at something that seems to be nonpolar versus something with fluorines that should be polar. And yet, the boiling point of the nonpolar thing is greater. So you have to come up with a reason why. Now, first off, you should be able to recognize that you're not breaking bonds. Intermolecular forces are being broken, but not covalent bonds. So it can't be the first option here. Hydrogen bonding is not going to be the case because there is no HF bond within there. So that's not a true statement as well. CF bond is more polar than CH, sure, but then wouldn't that lead you to believe that the CF compound would have a greater boiling point? No, the only acceptable answer here would work is that it's a longer chain. Therefore, it must have more dispersion forces. I took that question straight from an old AP exam. Okay, to make a gas behave ideally means that it doesn't interact with other gas molecules, either as they pass by or as they collide. So that's typically going to be at higher temperatures and lower pressures. So notice then to behave non-ideally, the student selected the last option, low temperature, high pressure. They're slow, they're squished together, they're more likely to interact. Again, question number four of our four different solids, because the one I don't see here is the molecular ones like H2O. It's just matching up some of the properties with that type of solid. Now, if I move into water in an ionic solute, so notice ionic solute, that would be ion dipole. And if you had this version of the test, then hopefully you signed up to grade the Gatorade lab with me because I specifically pointed this out. Now, if you had a nonpolar solute, for example, that would be dipole induced dipole. The water would be the dipole, inducing a nonpolar, making it have a dipole. And if it was a polar solute, it would be dipole dipole. If aluminum nitrate were dissolved, notice if these water molecules, it's the oxygen end that's next to the solute. And since oxygen is partially negative, that must mean that this is a positive particle. So that first off tells me that the second answer here, this open circle, is aluminum +3. Secondly, similar to a question that we had in class, if it's 2 molar aluminum nitrate, that means the molarity of aluminum is 2.0. However, since there's 3 NO3s in that formula, it'd have a 6 molar nitrate concentration. And if this is the speed for hydrogen, helium is a larger atom, so the graph should first off be skewed to the left. Secondly, since it's skewed to the left, it should be taller as well. And you can see that's why that student picked that particular problem. Again, something like this was on AP Classroom, and something like this was directly from class as well. But knowing how to read graphs and diagrams like this one, graphs like this one, important for an AP Chemistry student to know. All right, here we go. If you are given a temperature and a pressure, and here is a volume, and we're asking you for moles, hopefully you identified as this student did, it's PV equals nRT. Now, some of you kept your pressure in torr, and then you used the R value for torr as well. That's perfectly fine. But now molar mass is your grams per mole. If you subtract these two mass measurements here, that'll give you grams. divided by your moles gives you your grams per mole. They have 45.2 grams per mole as their response for that particular problem. Finally, if this gas were to be dissolved in water, identify one variable that would increase its solubility. So to get gases to be dissolved in water, you need them to be either at low temperatures, so they're moving slow, so it's easier for water to attract, or you need them to be at high pressure. Because at high pressure, and we're talking about outside pressure, so imagine here's your cup, high pressure pushing down, it makes it harder for the bubbles to escape when there's a high pressure pushing down. It's not putting it in a smaller volume or anything like that. It just makes it harder for that gas to escape. Okay? Again, some of you might have had to answer if it was less soluble, and numbers were different for everyone as well. Okay? First question here is your run-of-the-mill dilution equation. If I have 2.00 molar copper nitrate and I want to make 0.025 in 100 mils, how much do I need? Here's your M1V1 equals M2V2. They get 12.5 liters, or because I only gave them 2 sig digs, they rounded to 0.13 instead. Looks like this probably should have been 0.013 or 0.0125 because it doesn't make sense that 100 milliliters would make 130 to begin with. So little error there. Approximate molarity falls between 0.1 and 0.2, so they just looked at the data to try to figure that out. And then number 3, based on your previous answer, calculate the number of grams. Well, this student said, how about 0.150 molar? Did molarity times liters, because I say it's a 75 milliliter sample, and that got moles. Moles times the molar mass would get to the final answer of 2.12. And then which student or subject created an error? When you look back at the data, so if I scroll up just a little bit here, if you look back at the data, again, if we assume this value and this value hold true, it should be increasing throughout. So either group number 2, their concentration is higher than it should be, or group number 3, their concentration is lower than it should be. And really, it depends on, are you adding too much solvent by mistake? So too much water, are you watering it down? Or did you have too much solute to begin with? So let's look at this student's response. They said group 2 made an error in calculating the solution because the absorbent value is higher than it should be. This means they diluted their solution incorrectly by either adding too much solute or not enough solvent. So either way, they made it too concentrated is what they're trying to explain with this blurb right here. Number 1 mistake I would guess students made on this problem is remembering that hydrogen is a diatomic gas. Again, multiple choice in years past was done without a calculator, and you could do that as well here. If it's 20 grams of hydrogen, hydrogen has a molar mass of 2.02 because it's H2. That means I have roughly 10 moles of hydrogen. Helium has a molar mass of 4, so that means I have 5 moles of helium. Add that up, I have a total number of moles of 15. Why is that important? Because this is a partial pressure problem. And what I need to do is figure out my mole fraction. So if this is asking for hydrogen, I would take 10 divided by 15. Well, that's 2/3. And then 2/3 times 3, oh, what do you know? 2/3 times 3 gives me 2 atmospheres. But I bet a lot of people got this one wrong because they didn't treat hydrogen as a diatomic. And as we get towards the bottom here, potassium iodide is ionic, which means it would be very easy for it to dissolve in something like water. However, something that's really non-polar, like say hexane, C6H14, it would be difficult for it to dissolve in. So that goes over the portion of the test that was in person. I'm not releasing a recording for the take-home test, partially because answers vary so much because of how I formatted it. Also because those of you who will be taking the retest on Tuesday, you will not see material that's based on that. You'll see material more that's based on what you've seen here. So if you have any questions or you do want to look at that one specifically, just reach out to me and we can go over that on a one-on-one basis. Otherwise, hope you guys are doing well, and I will see you in class on Tuesday.